routine processing activity is repetitive. As you watch the film, look out for this repetitive activity, because at the end we'll explain how repetition can be dealt with when designing a computer program.
We've come to the Royal Bank of Scotland to see how one of the major clearing banks uses its computers. Now, computers are important in banking. For example, on an ordinary cheque, there are numbers at the bottom of the cheque which are in a special computer format. And the bank uses these numbers in order to identify individual accounts.
We asked Campbell Doherty, the manager here, about the importance of computers and how they have affected the way he deals with bank accounts.
Computers are very important to bank managers nowadays, and this due principally to the increase in the number of customers and the transactions passing through their accounts. When I joined the bank at first, all of these transactions were recorded in a ledger very laboriously by a clerk, where he sat and posted the various entries, debits and credits, bringing out the resultant balances. Now, of course, all of the information is contained within the computer, and it produces on our behalf and for the benefit of the customer statements on the transactions that they have carried out over, say, a period of a month. Such a statement as this, where we see the various debits that have come through the account, the various credits, and the resultant balances.
All this information, debits, credits, and so on, has to be held by the computer, and not just for one customer. The Royal Bank has about 500 branches throughout the country, and information about customer accounts at all these branches is now held centrally in Edinburgh by the Royal Bank's computer system. Here at the computer centre, information is processed to keep customers' accounts up to date. And what we're going to do in this program is show you how the computer does it. We have to start by seeing where in the computer the information is stored. Here's our diagram of a computer's structure. The large amount of data has to be kept in the part of the computer called backing store. It's held in backing store until it's needed for processing. The data is organized in files. A file is a collection of data needed for some specific purpose. There's usually more than one file in backing store, but we're going to concentrate on the single file which holds data about customer accounts. We spoke to the controller of systems development, Norman Irvin.
We use 22 magnetic tapes to store the information about our customers' accounts. In the Royal Bank, we have 1.5 million accounts, so therefore each of those tapes will contain approximately 70,000 accounts. This tape, for example, contains all the accounts for our branches in and around the Edinburgh area.
But just what information is stored on this tape? It's information which is needed to produce a bank statement. Each line of the statement represents a single transaction, and the whole statement is just one record in the bank's master file. There's one record for each account in the master file. Let's see what a typical record might contain. The first item of data is a number. This number identifies the record, and it's based on the customer's account number. Next, there's the customer's name and address. And then details of transactions since the customer's last bank statement. For example, these two transactions were cheques. On the 6th of December, there was a cheque for £450. The number underneath is the number of the cheque. The following day, there was another cheque, this time for £412. So there are 4 items of information on this record. The number which identifies the record, and then the name and address and the 2 cheque transactions. We call each of these items a field. So this record has 4 fields. Other records will have different numbers of fields because there are different numbers of transactions on each account. When we put all the 1.5 million records together, we get the master file. And to refer to any particular record, we use the number in the first field. This number is unique to that record. In fact, the records in the file are stored in sequence, given by these identifying numbers. A file ordered in this way is called a sequential file, and maintaining the records in this sequence is vital for the way the file is brought up to date.
The method we use to update our master file is batch processing. The new transaction information is collected into a batch during the day and is then used to update the master file that evening. So we can therefore say that the updating process takes place on a regular scheduled basis, once every night. And when we update this master file, we don't physically change the file. Each night we create a brand new master file by copying the previous day's information from the master file, and in the process we include the new transactions in the new master file record.
So records are copied from one tape to another, and in the process the new transactions are added. Let's see what happens to a typical record during this process. File processing uses the computer's working store, so a copy of the record is made inside the working store. Now, if there's data about a new transaction, this is added to the copy of the record. These copies from the working store are used to build up a new master file. But how does information for updating the file get into the computer? Most of the information comes from the bank itself, when customers transfer money in and out of their accounts. For example, cashing a check.
Thank you. Just like to sign the back for me, please.
We've chosen to watch a check being cashed because this transaction affects only one customer's account.
How would you like your cash?
£40 in fives and £10 in singles, please.
This transaction is to withdraw £50. So what the computer must do is debit the account by £50.
Here.
To do this, the check is taken from the cash desk into the terminal room. These terminals are connected to the bank's central computer. And this is where the information is typed in. Here's our check. And there's the debit for £50. Our transaction, and many more transactions input during the day, are stored, ready for the batch update process later that evening. It's now time for the operators to run the program which updates the master file. The program's name is Caustic. CAU stands for Current Account Update, and the program begins by asking the operators to mount 2 tapes. The first tape contains the old master file, and the second is a blank tape for the new master file. The program continues by displaying information for the operator to check. If the information is correct, the operator instructs the computer to begin the updating process. To see how the updating process works on the complete master file, we'll look at a simplified version. We'll represent it on the left of the screen. And on the right is a transaction file. That's a temporary file containing all the transactions entered during the day. The processing takes place in the working store. We'll represent working store across the center of the screen. We've arranged for the records in both files to be stored in order. The first item to be processed is the first transaction. That has to be joined onto the corresponding master file record. So a copy of the first transaction is brought into the working store. Next, we want a record from the master file. We start at the beginning of the file and copy the first record into the working store. Here, the transaction in working store is for the same account as the master file record. The computer can test this by checking that the identifying numbers match. So the new transaction details are added onto the record. And now the updated record can be used to start a new version of the master file. That's the story for the first transaction. Now, the next transaction can be processed. Copy it into the working store. And also copy the next master file record. But this time there's a difference. The transaction isn't for this account. The identifying numbers don't match, so this record isn't changed. It's copied directly onto the new master file. The same thing happens with the third master file record. It goes into the working store. It doesn't match, so it's copied unchanged onto the new file. Now for the fourth record. Into the working store. And this time it does match. So the new transaction is added onto the record. And the updated record is copied to the new file. And so it continues until all the records have been processed, making a completely new master file. This method, taking transaction records one at a time and working through the master file in sequence, is a standard technique for processing a sequential file at high speed.
On average, the computer can process about 70 records every second. To achieve this, the transaction file must therefore be in the correct sequence. But transactions arrive at the computer center from our branches in random order. Also, we have a great many transactions arriving from other sources. For example, yesterday, we had to process about 175,000 checks which had been presented for payment at other banks. So what we do is we store all these transactions on magnetic disks just like this. And then at about 5 p.m., after the collection process has ended for the day, but before we start the master file updating run, we have to get all these transactions sorted into account number sequence. So what we do is we take all the transactions from the various disks, we sort them, and then store them in a single disk bank. And this is the disk we use for the updating run that evening.
And that's another feature of batch processing. If the transaction records were in a random order, like this, then the computer would waste time going backwards and forwards to find records that matched. So instead, the transaction file is sorted into the correct sequence. Then it's easy to work through the two files, record by record. With this technique, we just start at the beginning of each file and work our way through to the end, reading each record only once. That's the essence of batch processing. We can summarize what's happened in a system diagram, which shows that transactions are first collected on several disks. At this stage, the transaction data is in random order. Next, it's sorted and combined on a single disk. This disk is used to update the master file held on magnetic tapes. The updating process creates a new version of the master file. And it also produces a large amount of printed output. Much of this printout consists of statements for bank's customers. Blank statement forms are fed into a line printer, and it prints information about each account onto the forms. Then the statements are sent off to the branches, but getting them there can cause problems, as Norman Irvin explains.
Each night we have to send reports and statements to our branches to arrive the following morning. For branches in the Edinburgh area, there's no problem at all. However, we do have a problem, for example, in the case of Kirkwall in the Orkneys, where the output has to be dispatched by 8:30 p.m. in the evening to arrive in Kirkwall the following morning. But of course, the updating process is seldom completed before 11 p.m. each night. So we get round this problem by taking advantage of the fact that the master file is contained in 22 separate magnetic tapes. And we simply arrange for those branches furthest away from the computer center to have their accounts on the first tapes to be processed. In this way, we can produce our output reports in 22 separate batches according to the geographical location of the branches.
This batch processing operation happens every night, 22 times, once for each tape in the master file. And each tape is updated by copying. Is all this copying really necessary?
You might think it's a waste of time to copy the records on our master file every night, but we think this is the most cost-effective way of doing things. And remember also, as a bank, we really are obliged to balance our books every night, down to the last penny, and this can be quite easily done as we produce the new master file each night. And when we complete the updating process, we don't throw away the old master file. For data security reasons, we keep several generations of our master file, so that if today, for example, we have some damage to our master file, we simply reconstruct the information from yesterday's master file.
And that's a bonus from batch processing, because every day a new master file is created. The previous version of the file is simply stored away, but next day the new master file must itself be updated. This means it becomes the input to the updating process, and the output is yet another new master file. And so it goes on, day after day. Each newly created master file is the file which has to be updated the following day.
As you were watching that film, you should have noticed that the main activity of processing account records can be described like this. Read a record, process that record, write it out to a new master file. And this must be done lots of times, once for each customer record. The way we cause the actions to be repetitive is by specifying a loop. We say, loop while some condition holds. In this case, the condition is going to be while there are records to process. This specifies that the loop keeps repeating while there are records available and stops when there are no more records to process. To mark the end of the loop, we use the word repeat. So that's the principle of a preconditioned loop, but in practice it's not quite so simple. This is where the trouble lies, in the loop condition, while there are records to process. How does the computer know whether there are any records available? It must try to read the next record. The loop keeps going until it can't read another record. And then the next time the condition is checked, the loop will finish. Now that's fine once the loop has started. But how does it ever get going in the first place? When the computer starts working through the program and comes to the loop for the first time, it won't have read any records yet. So it won't know whether there are any records available. The program won't work. We say that the loop has not been initialized. So we have to change the design of our program. Inside the loop, we're continually reading the next record. But for initialization, we have to read the first record before the loop starts. That way, the computer will know whether the loop must be performed for the very first time. And that sorts out initialization. But in doing so, it messes up what happens inside the loop. Let's follow it through. We've read the first record, and we carry out the instructions in the loop. But the first instruction inside the loop tells us to read the next record. And that'll be the second record. We've already read the first record outside the loop. So when we process a record for the first time, it'll be the second record that's processed. The data from the first record will have been lost. Now that's not satisfactory. The instruction to read the next record has wiped out the first record. We do need an instruction to read the next record, but it obviously can't stay where it is. So where should it go? To cure the problem, we have to put it after the instruction for processing the previous record. This may seem peculiar, but that form of design will be successful. You can convince yourself that it works by checking it through. Take a file with 3 records. Read the first record, and then the loop condition is satisfied. So we go round the loop. Process the record, and then read the next record. That'll be the second one. Now, back to check the loop condition. We've read the second record, so there's a record to process. We process it, and read the third record. Again, back to check the loop condition. We have a record, so we can process it. Now we must read the next record, the fourth record. But there isn't a fourth record, so when we go back to the loop condition, there isn't a record to process. So the loop finishes, and we go on to the rest of the program. So, to summarise, this is a preconditioned loop. That is, a loop controlled by a condition at the beginning. There's also some initialization, which is executed before entering the loop, and in this particular case takes the form of a read instruction. The actual instructions inside the loop are repeated for as long as the condition holds. This kind of loop structure is described in Practical Computing Booklet 3, and it can be used for processing records in a typical batch processing system.